Hi, let me introduce the layout and cross-section of a glucose strip and use it as an example for other electrochemical biosensors as well. So one of the things that I want to mention is this is what the glucose strip can typically look like. If we look at the main components, we can have this thing called a base layer, and I will describe this in more details in a minute. We have the space layer. We have the enzyme deposition. In the respect to glucose, this can be a glucose enzyme. And then we have the what's called the top layer, which goes over the top. This is often transparent. And it's quite useful because it helps the user actually see that their blood, for example, is flowing in and filling the chamber. Now, what we're going to do on the next slide is actually talk about a couple of cross sections of these glucose strips. So if we take a cross section across here, then what we have again is the sheet or the substrate. It's often PET, polyethylene tetraphthalate. And on top of that then is printed some conductive materials. This has sometimes been gold, in the past it's been platinum, and these days if we're talking specifically about glucose strips or in biosensors in general, it's actually a very good idea to use carbon just because of the cost of materials. Even though many people are very keen on gold, you can always make the assays work on carbon, and I think that's generally a good idea because otherwise you are going to be facing some real costs when you try to scale up later on. That said, the next layer that goes on top then is the sometimes called the insulator. In some industries they'll call it the dielectric, but it's, as you can see by its name, it's not meant to be conductive. It's meant to isolate those conducting tracks. Now I want to draw another cross section across this glucose strip, and if I draw a cross section here, then what we have again is the same sheet as before. We have our conductive tracks printed down. As I say, I would suggest keep them to carbon. Then we, for example, in the state of a glucose strip, have a enzyme deposition printed down. This would just be deposited down by a robot and dried, and it's got the enzymes and the bases and the electrolytes all necessary for the assay. Now there's another layer that goes down here as well. It's a double-sided adhesive that's been cut. In the particular case here, it's been cut into a kind of rectangle, and it forms the walls of a microfluidic channel. And then to kind of top that channel off, we have the top layer. There will be more videos in this series, but if you've got any questions for ZP regarding glucose strips or biosensors in general, please don't hesitate to reach out to us. Okay, thanks very much.